Hello everyone, it's Peter here, Piotr Wisner. How are you doing, guys? So, a bit exciting news. Uh, I've spent some time, and believe it or not, I thought it won't be possible to use ChatGPT to have some answers about inverters, but actually it turns out that it's really helpful. Now, I didn't know that there are various topologies. Of course they are, but I didn't know, and so I was able to meet the most common topologies about inverters, and I can say I'm either after full bridge or half bridge, probably the first one which we're gonna build on our own, not based on the Electronoops design, open source design. It will be half bridge. And I had a conversation with ChatGPT, and I will be validating that data as well. So I would like to share this, what I've asked, and maybe those who understand the topic, maybe they could just help me understand what questions I did ask wrongly, which questions I should re-ask again, and I'll tell you about the prices as well. Okay, so let's switch to the screen again. Let's switch to ChatGPT and let's scroll to the very top of that conversation. So I can say that can I move? I can't move. Okay, I know I can't move. I want to move so that you see from the top. Okay, so yeah, building an inverter. I've got 20 plus years experience, and why I had it is because it was always saying that you need to refer to a specialist, blah 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 blah. Yes, so I was just annoyed with those answers, like, come on, and fixing electronics, I'm okay. So that's why I've done it. Yes. So you see the question, and fixing electronics but no knowledge about the design. I'd like to build a DC 12 volts to AC 230 pure sine 50 Hz 500 watt inverter based on the topology half bridge. Can you help? And we get certainly. It can be challenging, but with experience in electronics it's definitely doable. So you see, it's okay. Yes, now choose the half bridge topology, and that choice is a good choice for 500 watts inverter because it can handle higher power levels than a single-ended topology. It also provides better efficiency and can produce cleaner output waveform, which is good. Now select components. Yes, variety of components to build your inverter, including MOSFETs. So I went and I said, okay, so your point number one is sorted. I'd like to talk about point number two next until I'll be ready for the next point. I'd like to select, I know you shouldn't add it, but it's okay. I'd like to select components like MOSFETs to start with. What parameters I need to look at in them. Yes, great. Let's focus on selecting the MOSFETs, and here voltage rating, current rating, RDS on, gate charge, package, and then when selecting MOSFETs, blah blah blah. Yes, so you can see the answer is above calculated for 12 volts DC input type of inverter. Just because I've seen this answer here, yes, and it was shown 24 volt input. Yeah, so that's why I've re-asked the question, so that I'm not, and I apologize for the confusion in my previous response. I mistakenly calculated the MOSFET. You see, so it does make mistakes and does correct them on demand. That's a good thing, but you need to be careful with what you're asking. Yes, so you see, we know we need a rating of at least 42 amps. Yes, well, of course that would be the maximum, and these MOSFETs wouldn't live for long, so minimum would be 60% if you would use it 100%. If you don't want to use it, like 100%, then of course even more. Okay, so let's see, let's say we need 42 ampere MOSFETs. Yeah, that's why I said about 60. Bigger margin, can you MOSFETs, and this I can find online. The rest I'm struggling with. And this one, yes, this one, look, shop, I can buy them even. I knew some of these shops like Mauser, DigiKey, I knew them. I didn't know these two, yes. But now look here. Why in point 4 in the list of all MOSFET is on semiconductor, this one, its datasheet says 20 volts and 4 watts, so it's no match to my inverter, for my inverter. And look, I apologize for the mistake in my previous messages. Yes, you are correct. The semiconductor is listed in point 4 is not suitable for your application. It has a maximum, you see. So please disregard, you see. So that's you need to be careful what you're asking. What would change if I use DTP 3205? For those who don't know which one it is, I can show you guys. I've got this poor quality inverter which has a dead, I think, transformer, and now I'm arguing with China. I've ordered 3 more of them, by the way. So these MOSFETs are those which I'm talking about. Those are DTP 3205 MOSFETs. These are cheap, by the way, yes, but let's look on the answer. So you see the DTP 3205 MOSFET is suitable option for 12 volts DC to 230, blah blah blah, yes. Gate RDS on, yes, that means it may dissipate more power, yes, when it's turned on. Next, heat dissipation, yes. So overall it's a good choice, yes, inverter, but you should consider the trade-offs between the gate discharge and RDS on when selecting MOSFET. And based on this one and on this high frequency yellow black transformer, it using 20 watts of power, so it's correct what is shown. You can watch videos from Electronoops or from Great Scott, and they are pointing out that it's unfortunately that's the case. Those are 2 main factors, yes. Plus, of course, controller might be set in a bit odd way. So overall is a good, yeah. How many MOSFETs will I need? You know, I'm just trying to act. I don't know anything. I don't know how the half-bridge topology is built. If you know, you would know how many MOSFETs do you need. But, you know, of course, the number of MOSFET that will need in inverter, yes, that's what's written here. And current rating of 75. Do I need to add a dead zone? Because it didn't say anything about it, yes. In switching of the MOSFETs, because that's a programming side of the controller rather than about the MOSFETs. Yes, you will need to add a dead zone. You see, if I wouldn't know it, it would just, you know, like it's not relevant at this stage, yes, because it's about the MOSFETs and it's programming side of the MOSFETs, not the type of MOSFETs I'm gonna use. But it's worth understanding, yes. I've learned it because thanks to ChatGTP, I was watching videos about it. And now I start to learn more, and I've learned that there is something called dead zone. Yes, so you've got the answer for it. If I use this MOSFET, which I could find, it's about 10 quid plus shipping probably. How many I would need? Yes, so it's a power MOSFET. Maximum current rating is 120 amps, and maximum voltage rating is 650 volts. If you're using this MOSFET in your half-bridge inverter circuit, you will need to ensure that the MOSFET is operating with the safe operating. So this inverter maximum need to be handled approximately 32. However, I mentioned earlier, this is a good choice MOSFET that the higher current rating. Maybe you pause it, you read it, you'll know, yes. So even though, you know, I would say 2 is the minimum because it's a half bridge, you open, you close, and the second half has to have the dead zone in between and have to open and close because it's a half bridge. So, you know, so it shouldn't say about 1, but it said about 1, but that's okay, you know. What that time would be recommended in my application? I would say that this might be a bit overkill to be true, so it would be nice to have this overkill because it would not use so much of its own potential, yes, so we wouldn't use. So what dead time would be recommended in my application? Yes, so then it replied, make the calculation and so on. How many transformers? You see, again, I'm pretending I don't know. how many transformers? Of course, 10 transformers I need, yes. For your farm, 500 watts, blah blah blah, 50, yes, and so on. In summary, you will need one transformer, of course, blah blah. But there are inverters which I'm opening, and there is more than one transformer. I think they've made it. I don't know why they've made it with their topology and their stuff, so maybe they said it's good to have, you know, like a 500 watt inverter and have 2 of those or 3 of those. Yes, it's just different topology, or they had it made it cheaper this way. I don't know. You know, like maybe they had good promotion on some transformers and they said, hey, we've got so many of those transformers, maybe let's build inverters. So there might be a variety of reasons, but it's a good thing that it's telling about the 600 watts transformer just to have this extra space. Yes. Are we talking like I would not know? Yes, of course it's a switching. We use MOSFETs to switch. We're talking half bridge, and yeah, okay. For your application, you would need a high frequency, yes, rather than traditional linear transformer. This is because HF transformers are smaller, lighter, and more efficient than linear. Yes. Can you calculate a specification like primary, secondary winding, etc. for my application? Yes. So look. It's showing us how many amperes is on the input current, yes, and that's power input, voltage input divided in voltage input and equals amperes, yes. And then, you know, next determine the required secondary voltage, yes, as well, which we have here. So it specify everything. It's 217 amperes on the output needed. So you see, then calculate number of turns, done it, 50 hertz in your case, showing the core material of ferrite, which is permeability of 5000, and it's talking about the inductance, yes, here. So that's it. Now it's a calculation as well here, flux density, yes. Using this formula we can calculate the number of turns required. Of course, some of this is guessing, yes, but we can then use turn ratio to calculate the number of turns required for the secondary winding this time, and choose the suitable core size and the wire. Now this is just example calculation, and the actual transformer specification will depend on the specific requirements and constraints of your application. Again, can you calculate the wire gauge as well? Yes, because I thought it will go beyond and we'll add it. It didn't. Okay, so sure, wire gauge as this, so it calculated as well. Oh, that's it actually. Okay, so let us move this. Okay, so that's everything, guys. That's nothing. So you see, so we've got it, and we can ask it to convert to millimeters, yes, because that's for the primary, that's for the secondary. Can you calculate the primary and secondary gauge to millimeters? Yes, sure. 1/8 using the conversion factor is C00, so it knows what we're talking about. And secondary, yes. So you see, that's what it is. I would say it's a great help, and I would say it's more than possible to build. As I said, I need to verify the data. Now about the prices. You know, the MOSFETs, if I would go and buy 1,000 of these MOSFETs, yes, I could get a price of about £5 plus shipping. But the transformer is a biggie here. The transformer in China cost $40 plus taxes, like, you know, import or VAT or something like that, plus shipping. And when I've asked about the sample, to send me a sample, only for the shipping, $130. I said, oh. And that's toroidal. that's toroidal, and that's why I want to build two. I want to build this one from Electronoops, replace those cheap MOSFETs into a better ones, those for £10 later, recalculate it and replace the controller here to ESP32, and that would be probably the final result of the PCB design. Okay, then when we will have it, then what's happening is we could try to replace this transformer here with that toroidal, so that means the rest would stay as is, I'd say. Yes, the values will change when those components will change and we need to redesign it, but I would say it's worth, because if Electronoops and Great Scott have shown that there is a 20 watt power consumption in ESG002 controller used design in those, yes, so those MOSFETs are cheap, and RDS on, you see heat dissipation, all of it, you know, it's just not there. If we could replace it with something else, we should gain something back, so it should heat a bit less and it should be more efficient, I'd say. How much we will, again, I'm not a designer, I just fix electronics, I don't know. Probably I can ask, probably I can calculate it, yes. So yeah, that's the plan for the inverter. What else I can tell you? I've spoken with China, I've spoken with a manufacturer of transformers there, and I've started talks with one British company as well, which produces transformers in Britain. So the question now is, can we get this in the UK, or do we need to order it from China? Yes, so first we will base on this, we will build it, we will try to make it better, and then the next step is we will try to just change it completely. Yes, change it completely. Yes, I know I'm not an engineer, I'm not even a technician, I didn't even graduate it, I only fix stuff since the 90s on a daily basis, and I just want to build something open source that it won't pile up as those other inverters at my home, because either the controller is dead or transformer is dead, and I don't know how many windings is on primary or secondary. I would have to unwind it to see it, and then what, I'm gonna rewind it? You know, it's not that worth. So these things are ending up sooner or later in the bin, because I'm learning about the topologies, if I'm learning about everything and the design, after some time I will be able to use those components and build my own design from it, so they won't end up in the bin. I've got a Victron Energy here, people saying it's such a great company, Victron Energy. You've got toroidal, yes, it's faulty, and guess what, the voltage is coming into the controller and controller doesn't turn on, and it's not under warranty, so now it's to the bin. And you spend few £100 on it, and you're putting this to the bin so that you can spend another few £100. That's unfair, guys, that's really unfair, because even if the transformer will cost you £100, and let's say the labor cost would cost you 30, you'll spend 130, but you have it fixed, whereas you'll spend £300 to £400 minimum to buy another one and install it and pay someone to do it. Yes, so I'm saying let's make something open source, fixable, and I'm looking for people who would like to join me on this trip of building an open source inverter. Yes, two types, top notch one, and second is like a mid class, you can say. Yes, that's not the cheapest, but it's a mid class. And then replace this EGS002, program ESP32, because we will have Wi-Fi built in. Yes, so I would say that one is better. Replace these cheap MOSFETs as well and get some IGBTs or some better MOSFETs. Yes, yeah. So I don't know what else I can say. I'm still newbie in this. I'm still a rookie, guys. Probably will take me several months before I'll be, you know, I'll be talking properly about it. But thanks to the ChatGPT thingy and thanks to talks with other people, I can say I'm learning. I've got a progress in learning, and there is a group of people, followers, which are building this with me, or they will provide funds, as they did already as well. They will provide funds so that when I'm buying, and I need to buy a minimum of 5 or 10 of something because it's not worth buying one, then they say, okay, I want another inverter, let's say, yes. And the downside only is that I will be not only soldering for myself, but I'll be soldering for themselves. So for them, not for themselves. So that's only the downside. But at least that's helping me because I don't have to spend so much. I don't have crowdfunding where people could, you know, like crowdfund it. Somebody would be able to help out with this project. That would be awesome. It would be done quicker, but because I've got limited budget, and I've got a whole photovoltaic system to be built as well, and I need to spend more on the car, and I just spend like we just spent £1,000 on the car, yeah. So yeah, now turbo is to be replaced as well, or rejuvenated, yes. And so I can't do it as quickly, as efficiently as I would, and because of that it will take me time to learn it and then ask ChatGPT proper questions, and then have these questions and looked at by professionals who are designers, and they can tell me what I'm missing, what is right, what is wrong, what should I ask again, yes, and then take it from there. That will take us few months, guys, to build these two inverters, yes, probably 500, maybe 1 kilowatt each, but those two definitely. So thank you for watching. See you in the next video. If possible, leave us some like button over there, and here's likes to you for liking the video. Thank you, and see you in the next video. Bye bye.